All right, welcome back. We have got a bunch of practice problems to do over Chapter 12 and the sections that we covered. So why don't you pause the video here to answer A and B about electrolytes and non-electrolytes. Hopefully for part A, since we're told that it is a weak electrolyte would contain mostly molecules and a few ions. And hydrochloric acid, it's a strong electrolyte, so it would contain only ions. Let's look at the next sample problems. Pause the video here. Let's look at our answer. We are told that 34 grams of KCl in 100 grams of water is the solubility. Now, 200 grams of water is double that, so you might have just said, well, 34 doubled is 68. But hopefully you write it this way, because if we have something that's not exactly double or it's not an easy number to use, we would take that 34 over 100 and we would just multiply it by however many grams of water. Notice grams of water and grams of water would cancel out, leaving us with how many grams of potassium chloride could dissolve. For part B, because 75 grams of KCl exceeds the maximum amount, which is 68 grams, that can dissolve in 200 grams of water, all we do is we subtract 75 minus 68, which would tell us that there is 7 grams of solid, undissolved potassium chloride at the bottom of the container. And therefore, the potassium chloride solution is saturated. Let's look at a couple more problems about saturated solutions. Pause the video here. Let's look at our answers. We're told that the solubility is 65 grams of potassium nitrate per 100 grams of water. So I wrote our conversion factor like this and then times it by 120 grams of water. Notice that grams of water and grams of water cancel. So that would give me 78 grams of potassium nitrate that will dissolve. For part B, we want to know how many grams of water are necessary to dissolve 110 grams of KNO3. So I was thinking, well, if I'm going to multiply 110 grams of KNO3, I need grams of KNO3 on the bottom. So I just flip-flopped this conversion factor. So I said 100 grams of water on top per 65 grams of potassium nitrate and times it, and those would cancel out, leaving me with grams of water. And I got 169.23, but we only have two significant figures. So I rounded to 170 grams of water. This question is looking at soluble and insoluble compounds. Why don't you pause the video here to do these top two and the bottom two. Let's look at these answers. Sodium phosphate is soluble because any compound that contains sodium ion is soluble. If we were to look at our solubility chart, it would say that most phosphates are insoluble, but any alkali metal is an exception. Calcium carbonate is not soluble. Magnesium chloride is soluble because, if we looked at our chart, all chlorides are soluble unless, and magnesium is not an exception. Barium sulfate is not going to be toxic, like the question said, because barium ions are toxic if ingested, but barium sulfate is insoluble in water, so it's not going to produce those barium ions as it passes through the GI tract during an X-ray. This next one, we're looking at double displacement reactions. These are our reactants. Both of these reactants are soluble in water. Predict whether a solid might form in each of the following reactions, and if so, write the net ionic equation for the reaction. Let's look at letter A, ammonium chloride and calcium nitrate. They're going to switch the cations and the anions. So ammonium, instead of being with chloride, ammonium is going to be with the nitrate. So ammonium nitrate would be one possible product. And calcium is going to join with the chloride, CaCl2. Again, that's because Ca is a +2 and chlorine is a -1. If we look at our cheat sheet for our solubility rules, both of these are soluble. So therefore, there will be no reaction. This will not happen. Let's look at letter B, lead nitrate and potassium chloride. The lead is going to leave the nitrate and join with the other anion. So we will have lead chloride. We know that Pb is a +2 because of that too, and chlorine is always -1. And then the potassium is going to leave chlorine and join with the nitrate, potassium nitrate. Potassium nitrate on my solubility rules is soluble, so we wrote AQ. Lead chloride, though, is insoluble. Therefore, this reaction will occur because of this precipitate that's formed. And our net ionic equation for that is writing the Pb plus 2 ion plus 2 chlorine ions to give me that precipitate, lead 2 chloride. Here's a problem looking at mass percent concentration. Pause the video here and see what you can put together. Let's look at these two. We were told that we dissolved 2 grams of sodium chloride in 56 grams of water. So the mass percent is we take the part of sodium chloride divided by the whole. So I took 56 grams of water plus the 2 grams of NaCl to get the total mass of the solution. So 2 divided by 58 times 100, round to 2 significant figures, would give me 3.4% mass NaCl solution. And the next one was 1.8 grams of magnesium chloride in 18.5 grams of water. So I added 18.5 plus the 1.8 to get 20.3 grams of the solution. Part divided by whole times it by 100, and with 2 sig figs, 8.9% mass for the magnesium chloride solution. This one is using mass percent to calculate the mass of the solute. Pause the video here and try to put together A and B. Here we go. Letter A, we want to calculate the grams of KCl. So that's my X, my part, over the whole, which is 225. So that's my denominator. And then I wrote times 100 to equal 8%. So then I just divided both sides by 100 to get rid of that, leaving me with X over 225 is equal to 0.08. And I just wrote 0.08 over 1 just to help me so I could cross multiply, and giving me X times 1, which is X, and then 225 times 0.08, which would give me, with 3 significant figures, 18.0 grams of potassium chloride. And for part B, I set it up the same. We wanted grams of potassium nitrate, so that's my X, over my whole was 45 grams of solution, times 100 equals 1.85%. I divided both sides by 100 to get rid of that, leaving me with X over 45 is equal to 0.0185, and then X times 1 is X, and 45 times 0.0185 would give me, with 3 significant figures, 0.833 grams of potassium nitrate. Here are 2 problems calculating volume percent concentration. Pause the video here. Let's look at A. What is the volume percent of bromine in a solution where I have 12 milliliters of liquid bromine in a solvent, carbon tetrachloride, to make 250 milliliters of solution? So I did 12 divided by 250 times 100, and with 2 sig figs I got 4.8% volume of bromine solution. And for B, the rubbing alcohol, 14 milliliters of isopropyl alcohol and 20 milliliters of solution. So 14 divided by 20 times 100 would give me 70, and there's a decimal point there showing that there's 2 sig figs. 70% volume of isopropyl alcohol solution. The next problem is calculating mass volume percent concentration. Pause the video here as you work through A and B. For part A, I took the 12 grams of sodium hydroxide over the 220 milliliters of solution, times it by 100, and with 2 sig figs, 5.5% mass volume of sodium hydroxide solution. And for part B, I took the 3.25 grams of magnesium chloride in enough water to make 125 milliliter solution, times it by 100, and with 3 sig figs, 2.60% mass volume of magnesium chloride solution. This problem wants us to work backwards to calculate the mass of the solute. Pause the video as you work through this. Here I set it up. It said that a topical antibiotic is 1% mass volume clindamycin. So I put my 1% as the final answer. How many grams of clindamycin are in, so I put my X for my grams of clindamycin, are in 60 milliliters, so that's my denominator, of the 1%. So then I just worked backwards. I divided both sides by 100 to get X over 60 is equal to 0.01, and I just put over 1 to help me with my cross multiplying. X times 1 is X. 60 times 0.01 is 0.60 grams of clindamycin. Pause here as you try to work backwards again to find the mass of these solutes. Letter A, we're told that we have a 2% morphine oral solution, so that's my 2%. And we were told that we had 0.60 milliliters, but we need to find out how many grams of morphine. So that's my x. X over 0.60 times 100 is equal to 2%. So I divided both sides by 100 to give me x over 0.60 is equal to 0.02 over 1. I did my cross multiplying, so x is equal to 0.6 times 0.02, and that gave me 0.012 grams of morphine. For letter B, we have a skin infection. The doctor orders 300 milligrams of ampicillin. Now we need that to be in grams, so that would be 0.3 grams of ampicillin over x milliliters times 100 to give us that 5% ampicillin. So again, I divided both sides by 100. That gave me 0.300 over x is equal to 0.05. And then I cross multiplied. This gave me x times 0.05 is equal to 0.3. And to get x by itself, I divided both sides by 0.05. That gets rid of that 0.05, and x is then equal to 6 milliliters. These questions are about calculating molarity, so pause the video here. All right, the first one, we were given 75 grams of potassium nitrate. We know that molarity is moles over liters. So we needed to get 75 grams into moles. So I added up 1 K, 1 N, and 3 O's to get a molar mass of 101.108. And that has to go on the bottom to cancel out, leaving me with 0.742 moles divided by the liters given to me in the problem. And with 3 sig figs, 2.12 molar, capital M, KNO3 solution. And the second one, 6.40 grams of the disinfectant thymol. So I took 6.40 grams and went grams to moles. I added up 10 carbons, 14 H's, and 1 O to get that molar mass, leaving me with this many moles divided by 2 liters of solution. And I got 0.0213 for the concentration of that solution. The next set of problems is calculating the volume of solution using molarity. Pause the video here to set it up. Letter A gave me grams of hydrochloric acid. I just took grams, went to moles right away. That gave me 4.4983 moles of HCl. We need to find how many milliliters, but first I'm going to go to liters because molarity is moles per liter. And we were told that it was 6 molar concentration. So I did 6, and I just put it over 1 to help me with my cross multiplying. So 6 times x is equal to 4.4983 times 1. So that is where I went next, divided both sides by 6 to get x by itself, which is my liters. We wanted milliliters though, so I just times it by 1,000. 1, 2, 3, 749.7 milliliters, but we only need 2 significant figures. So I rounded to 750 milliliters for letter A. And for part B, I took my 12.5 grams of sodium hydroxide and went to moles of sodium hydroxide using the molar mass. And that gave me 0.3125 moles over X amount of liters is equal to, the molarity is 2.50 molar. Again, I put over 1 just to help me with my cross multiplying. So that gave me 0.3125 is equal to 2.5 times x. And then I wanted x by itself, so I divided both sides by 2.5. X gave me 0.125, that's in liters, so I times it by 1,000. That'd be 125 milliliters of solution. Here are some more practice calculations involving concentrations. Pause the video here and try to work through them. Letter A, we're given 50 milliliters of 4 molar KOH, so that's a concentration and a volume, and it's diluted to a new volume of 200. So we're going to use this equation, C1V1 equals C2V2, and we're going to do 4 times 50 is equal to C2 times 200. And to get C2 by itself, we just divide both sides by 200. We should get 1.00 molar KOH. For the second one, we're told volume and percent of the first concentration. We see that it is diluted to a volume of 85, so that's our second volume. We need to find the new percent concentration. Divide both sides by 85, and we should get 2.5%. Here are 2 more problems involving volume of solutions. Pause the video here. For these two problems, we were looking for the initial volume, so VI, or V1, and we were told that we had 15% was my initial concentration, and it was diluted to 3%, and we had 125 milliliters. So I divided both sides by 15%, and that gave me an initial volume of 25 milliliters. The second one, again, we're looking for the initial volume, V1. We're told the initial concentration, and we're told the diluted concentration and the diluted volume, so we divided both sides by 2.4 to get an initial volume of 20.0 milliliters. Here are two more problems looking at solutions and reactions. Here's the equation that it's referring to in 12.14. That will help you with this. The first thing I asked myself was, what am I given? And I was given 225 milliliters of a 0.2 molar hydrochloric acid solution. So I'm given a volume, but I need my volume in liters. So I put that 225 milliliters into 0.225 liters. And molarity, if we remember, is equal to moles divided by liters. So to find moles, it's molarity times liters. And we could also look at our units. If I wanted to take away that capital M and write moles per liter, and I timesed moles per liter times liters, the liters and liters cancels out, leaving me with moles. So 0.2 times 0.225 gives me 0.045 moles of HCl. But I want to know grams of zinc. If I know moles of HCl, though, I can go from moles of HCl to moles of zinc, looking at that mole ratio. There's 2 moles of HCl for 1 mole of zinc. That gives me my moles of zinc. Then I can go to grams of zinc using the molar mass. 1 mole of zinc has a mass of 65.38 grams. And with 3 sig figs, I should end with 1.47 grams of zinc. For this next problem, we are asked to find milliliters of HCl, and we're given the concentration of HCl. Well, in order to find milliliters of HCl, and we know the concentration of HCl, we have to know moles of HCl. So that's what we need to get to in order to solve for this. How are we going to get to moles of HCl? And we're given grams of zinc. Well, whenever I see grams, I think, you know what, let's get to moles. So I went from grams of zinc to moles of zinc using the molar mass of zinc. That gave me moles of zinc. Then I can hop from moles of zinc to moles of HCl using the 2:1 ratio. That gave me my moles of HCl. Now I know moles of HCl and I know concentration, so I just have to do moles divided by the molarity, which is 0.235, and I put capital M here for molarity, but remember that molarity is moles per liter. So the moles and the moles cancel out, leaving me with just liters. And it wanted milliliters, so I just took our answer and I times it by 1,000 to give me 55.4 milliliters. There are 2 more problems left to do. You are doing fantastic. Pause the video here to work on these 2 problems. Let's walk through this problem. In this reaction here, we want to know how many milliliters of this concentration of sodium sulfate is needed to react with this many milliliters of that concentration of barium chloride. I always look at these and go, well, I gotta know 2 out of the 3 things for one of them. And I look at this barium chloride and I'm given volume and concentration, which means I can find moles of barium chloride. If I find moles of barium chloride, I can get to moles of sodium sulfate. And then I can find the volume of sodium sulfate because the volume is equal to moles divided by concentration, and we're given the concentration. So let's work through it. To find moles of barium chloride, I did the concentration times the volume. I had to get that volume into liters though. So that gave me moles of barium chloride. My mole to mole ratio was a 1:1 ratio. So I got the same number of moles of sodium sulfate. And then I took the moles of sodium sulfate divided by the concentration of that sodium sulfate. That gave me my answer in liters, and then I times it by 1,000 to get 17.5 milliliters. For this problem, Again, I'm given 2 out of the 3 details that I need for the sodium sulfate, giving me volume and concentration. So if I know volume and concentration, I can find moles of that sodium sulfate. So I multiplied volume times concentration, and I got my volume into liters. So I got 0.003375 moles of sodium sulfate. Then I went from moles of sodium sulfate to moles of barium chloride using my 1-to-1 ratio up at the top. So I got the same number moles of barium chloride. The question wants to know, what is the molarity? And molarity is moles divided by liters. So I took that moles and I took the milliliters and put it into liters, and then I got the answer with 3 significant figures, 0.174 molarity, or the concentration of barium chloride. Last set of problems here. Pause the video. Alright, this problem has a lot going on. We are looking for the volume of a gas. And so remember, if we're looking at gases, we need to think back to this last chapter. And gases, remember that PV equals nRT? If we're going to find the volume of that gas, we need to know pressure, moles, the R, and the temperature. Now it does tell us that we need to find the volume of NO gas produced at, we're given a temperature and we're given a pressure. So we know temperature, we know pressure, we know R. We got to get moles of gas. That's our only unknown at this point. Okay, so we need moles of NO somehow in order to find volume. What else are we given? We're given volume and concentration of this acid. If we know volume and concentration of the acid, we can find moles of acid. And if we know moles of acid, we can get moles of gas from that mole-to-mole ratio. So to find moles, we're going to take that concentration and times it by that volume that we were given. That gave me 3.3 moles of HNO3. Then, for every 2 moles of HNO3, there's 1 mole of NO. So I have 1.65 moles of NO, and that can go into my N. So PV equals N. My R is 0.0821. That's the one that has atmospheres in it. And I took that 100 degrees Celsius and added 273, so 373 Kelvin. Divide this whole right side by 1.2 to get V by itself. And I got 42.1 liters of gas. For part B, we want to know how many milliliters of this acid that has a concentration of 0.344 molar. So we want to know volume of this acid. First we got to get to liters, then we can get to milliliters. We're given concentration, so we need to find liters. And in order to get to liters, we need to know moles and molarity. We're only given molarity, so how do we get to moles? Let's see what else we're given. We're given volume of a gas, pressure of a gas, temperature of a gas. Let's plug that into that PV equals nRT, because we can do that for gases. We're given pressure, we're given volume. We can find moles because we know R and we know temperature. I just added 273 to it. So I multiplied these right 2 numbers, which was 24.0553, divided both sides by that. And I got N, this is moles of my gas, 0.046559 moles of NO2. Then I went from moles of NO2, there's 3 moles of NO2 for every 2 moles of HNO3. That gave me my moles of HNO3. And if I know that, then I can solve for my volume by doing moles divided by molarity. That gave me my answer in liters, and then I multiplied by 1,000. I got 90.2 milliliters of HNO3 would be produced.